Today we are building and visualizing indifference curves and budget constraints to calculate uncompensated and compensated demands. That is, Marshallian and Hicksian demands. So let's get started. This consumer utility equation states the consumer's preferences, and this budget constraint equation states the consumer's income and the market prices of good X and good Y. Finding the original Marshallian demands for good X and good Y is about shifting out the indifference curve just enough so that it intersects the budget constraint at a single point. The indifference curve is just a fixed level of the utility function along which one can make trade-offs between goods X and Y to remain on the same level of utility. To calculate this optimal point, we need to find the point at which the slope of the indifference curve and the slope of the budget constraint are equal. As you can see, we can use this equality to derive expressions for Y and X, which we can use to solve for the uncompensated Marshallian demands X star, Y star, and the numeric value of the consumer's utility. Thus, we have maximized Cobb-Douglas consumer utility subject to a linear budget constraint. I have another video where I simplify all the mathematics into 3 easy steps with numeric and graphic calculators I coded in the Wolfram language. To find the final Marshallian demands, we repeat the exact same process, but we use a new price ratio given by any possible price changes. Here we look at an increase in the price of good X from 2 to 4, which changes our price ratio from 1/5 to 2/5. Hence, we pivot the budget line inwards around the vertical axis with its corresponding optimized utility since the price of the good in the horizontal axis has increased. Thus, utility falls because less can be purchased of the good whose price has increased. However, we can change the consumer's income to go back to their original level of utility after a price change. This is called Hicksian income compensation, which now uses a utility constraint instead of a budget constraint. In the case of a price increase, the consumer will need more money to return to their original level of utility. Thus, we shift out their budget constraint with the new price ratio such that it intersects the original maximized utility at a single point. Lastly, we can now identify the Hicksian consumption effects. The substitution effect is given by the Hicksian demands minus the original Marshallian demands. The income effect is given by the final Marshallian demands minus the Hicksian demands. The total effect is given by the final Marshallian demands minus the original Marshallian demands. It is also given by the sum of the substitution and income effects. The compensating income change is just the compensated income minus the uncompensated income. In this case, the total effect of good X is negative because its price has increased, and the total effect of good Y is 0 since its price has not changed, so the substitution and income effects cancel out. All Cobb-Douglas utility functions exhibit normal goods since the resulting substitution and income effects always act in the same direction. I wrote a paper where I proved this mathematically for Hicksian compensation and Slutsky compensation in both Cobb-Douglas and constant elasticity of substitution forms, and derive conditions under which the substitution effect is greater than the income effect, and vice versa. Alternatively, if there was a decrease in the price of good X from 2 to 1, we would have these dynamics. The budget line would pivot outwards around the vertical axis with the new price ratio, and utility would rise as more can be purchased. Likewise, the consumer would need less money to return to their original level of utility, and we would shift in their budget constraint with the new price ratio. If you want to improve your grades and understanding, you can explore by yourself with any values you want with the numeric and graphic calculators that I have coded using the Wolfram language on my website. As you can see, all you need to do is click on the right of each number, delete the number, write the number you want, and press enter to make the calculators find all the respective optimized variables from your choice of numeric values. You can use these graphs to study how the equilibrium points move, indifference curves shift, and budget lines pivot as you change the numeric values using these sliders. My website is linked here and in the video description below. Feel free to check out my other videos and website for more tools in microeconomics, macroeconomics, econometrics, and industrial organization. If you found this video helpful, please like, share, and subscribe for more content in economics, calculus, and statistics. Thank you for watching, and I'll see you in the next video. Peace.